Good evening, my dear kids. Today's class will take the problems on the applications of refraction at plane surface. So, if you can recollect previous class, we had the discussion about the refraction at the plane surface, the Snell's law, and the apparent shift, other things. Now, we'll go for the further few more applications on the refraction at plane surface. Let me start the class. Okay, now in this class, we'll go for the refraction at the plane surface application. So, what are the basic applications? Already we have come across the there's an apparent shift, then apparent height, all that one. So one more applications let me introduce here. So let me consider a slab and let me place an object. Okay, I'm going to keep an object somewhere here. Then I'm going to weave it from here. Okay, this is slab of thickness T. Refractive index, let me keep it this as mu1. Already the apparent shift, what we studied, those concepts only I'm going to apply, not something new. Now the refractive index of slab be mu2, surrounding medium let it be mu1, this is mu1, and this is mu1. Let me keep below. Okay, where do the object will appear? I think this is a very quite natural thing. You try to weave an object to a thick glass slab, then where do that object will appear for us? Okay, we'll stick on to the basic like first the incident ray emitted by the object. It will emit the rays in all direction. It will emit rays in all direction. I'm just considering the incident ray which is striking this surface. So let me call this is P1. This surface is P2. Now let's assume that this is the denser medium. This is rarer. So what is the assumption? Denser, rarer, rarer. So the ray is moving from rare to denser medium. So it will undergo the refraction, the refracted ray will show like this. So this I'll produce it back. So here is what the image I1 will come. Again the ray is going to move from denser to rarer. It should bend away from normal. So the emergent ray will be finally here. So the object where it was, actually it is. What do you mean by object? Some flower. Now where the final image will be here, that one. So I'll say like a, can you keep flower? Okay, let's go for flower. Now where did it appear? It will appear here. There's a basic idea. You must have a background of these kind. What is object? Object is a real. The image flower, what you are going to see, that is a virtual. There's a basic idea, this one. So there's a real. Now why virtual? Because the refracted rays, you can also send a rays here. So this image is formed by the diverging refracted rays. No, the diverging refracted rays enter into eye, and the eye will see the virtual image of this one flower. So it will appear nearer, no? So it will appear nearer. So this part is what? The shift. we have to calculate this shift on what all parameters it depends. Okay, here first it will undergo refraction at M, then at N. So what we can do, so this is the no, normal, okay, this is the angle of incidence, theta 1, theta 2, theta 2, and this is theta 3. So you can apply the Snell's law and you have to solve this, nothing big that one. So what is the basic Snell's law? So at M, it will be mu1 sine theta 1 equal to mu2 sine theta 2. At N, mu2 sine theta 2 equal to mu3 sine theta 3. And we do discuss for paraxial rays. What do you mean of paraxial rays? The rays, the M will be very close to the P1. So for paraxial rays, theta will be very small, sine theta will become tan theta, then you have to further solve it, tan theta 1, so this will become tan theta 1, this will become tan theta 1, this will be tan theta 2, this will be theta 3. So from the triangles P1, M1, from there we are supposed to solve this. There's a one method, huh? Okay, fine. So here for paraxial rays, theta very small, so therefore sine theta will become tan theta 1. Now what we have to calculate? We have to calculate that shift S. That's our requirement. So there's a one method. So from using Snell's law solving, we can do it. Already we know the apparent shift. So can't we use apparent shift as it is? So suppose say that you are here, huh? You are here. So how you can apply this as slab? Let's assume that you are here. So where is the object? Object is in diagonal medium. You actually you can solve by this method. Tan theta 1, tan theta. What is tan theta 1? Use this triangle. P1M by P1O. Then tan theta 2 will be directly straight away from here, no? P2N by P2I1. Tan theta 3. P2N by P2I. So we'll get the required things. Hmm? So that is a one method. Try that method. Let me show you by another method which we usually prefer in the numericals. Suppose say this is the okay. This is an object. Okay, this is the brown color one. No, where is the brown color? It is here. This is the image, no, I1. So this is mu1. This will be mu2. So we are not understanding. Okay, I'll do like this. At least now, okay. So where the refracted ray is present in the medium of refractance mu2, and if you are here, then where is the object? Object is here. So this will be P1O. So any formula for P1I1 apparent depth, this will be like a rarer medium. This is a denser medium. So if this person weaving, so this will become boundary, no? This will
HY mu
become
we can
boundary. P1I1. I want from anybody answer.
P1O by
Ah,
P1O mu2 by mu1.
yes sir, P1O mu2 by mu1.
P1O mu2 by mu1. P1O. This is very important. See, what you learned now, can you apply this? Finally, it matters a lot because almost all numericals, we will use this approach. We can solve by this one. There's a more mathematical one. This will help. This is going to help us a lot. P1 I1 equal to P1O by mu2 by mu1. Okay, fine till here. What we needed, only we needed this distance. So it is something like P1O minus P1I. Now let's come for this one. After refraction, okay, this I1 will become object for this interface, and the eyes, the green color rays, what will read the eye. Though this I1 is there in the radar medium, you have to treat as if it is coming from I1. No? So here the approach will be little bit different. Please try to understand. This will going to really help you a lot. No, this will be everything the medium. Huh? Though I1 where it is in radar medium, but for the eyes, what happen as if the rays are coming from I1, as if they are coming from the medium of refractance mu2. Here's what I am here. So this is the human eye. Or we'll take another person. Is here. So then this M2. So where is the I1? I1 is here. The rays are coming as if from I1. So after refraction, and this is the boundary. I'll bring brown color. Where is that brown color? It is like this.
Sir, sir, P1O into mu1 by mu2 should come, no sir?
What is the refractoriness of the medium in which object is there? You are weaving from a medium of refractoriness mu2. Okay.
Yes sir,
Suppose
yes.
huh?
Got it sir.
Not like denser rather, in which medium you are weaving. Huh?
Okay sir, yes sir, yes.
I'll exchange this. We will write this is I. Rather than denser, rather better call mu2 mu1. There'll be more better approach here. And this is what P2. This was P1 we took it here. Now can we write any equation here? P2I. Now where is the object? Object is in a medium of refractance mu2 and the view from a medium of refractance mu1. And where do it will appear? It will appear at I. So any formula for P2I?
P2I1 mu1 by mu2.
Yes sir. P2I1 mu1 by mu2.
P2I P2I is equal to P2I1 mu1 by mu2. Okay, now this is the formula. Now these are the things which we are going to take help of it. Now what is needed? We needed just like the shift, no? P2 P2I can I write P1 plus P2 plus P1I? So some adjustments will make it here, and P2I1 also I'll make it adjustment. So this is about the background. Okay, now we'll go for the calculation part. P2i further, P2i equal to P2i1, I'll write it as P2P1, P2i1, P1i1, mu1 plus mu2. P2P1 is T, P1I1 already I have here this particular thing. I'll substitute that one, so that will become P10. Now what is needed for us, like a P2I minus P10 or P10 something. Okay, let me go for the next part of calculation, the shift S. Shift S is equal to, this will be P2O minus P2I. P2O is P1 plus P2, or say P2 plus P1 plus P1. P2I already we have calculated, so T plus P10 P1 P2 is T plus P10 P10 also get cancelled, so we'll end up with 1 minus mu1 by mu2. Very important formula. You check the book, no? There are around 25 numericals are there based on this, not one, two. This is a theory, nobody will ask you to derive this, only in IP exam next year at this time. But all the competitive exams, you need this formula. You should know how to use this formula. You can solve by the Snell's law, that one. So, but in the most of the numericals, no, we need approach of this one. That's why I just preferred it. What do you mean by mu1? Refractive index of surrounding medium. What do you mean by mu2? Refractive index of the slab. If the surrounding medium is air, then mu1 will become equal to 1. If surrounding medium is air, then mu1 will be 1. Okay. I'll just highlight it. Anybody having doubt, please clarify. I'll go for the applications of this one, no? You should try to solve by this method. There's another alternative method, mathematics. This little bit you have to apply more triangle solve. You can have this approach also and you'll get the same answer. No? Try it. No? Okay, now after getting this formula, we'll move on to the how to use this one. What is a mu1, mu2, all that one? So it is a shift in the direction of incident ray. What is mu1, mu2? Refractance of medium surrounding the slab. Mu2 is refractance of slab. What is T thickness of slab? S is the shift. Shift in what direction? In the direction of incident ray. Suppose say I have a slab. I have a slab. Here I'll keep some flower, and I'm going to weave it here. What is the direction of T is the thickness of slab, mu is a refractive index. What about mu one? Surrounding air, surrounding medium is air. So what is it? Where do this flower will appear? This flower will appear nearer. I should show dotted one. Oh, the flower should be a dotted one. This is the real, this is the image. Well, and what is the shift? Shift is in this direction. How much the shift is equal to? The shift what you calculate will be T into 1 minus 1 by mu. Okay, getting? And what is the direction of shift? Direction of incident ray, sir, we are not understanding. Suppose a ray will go here. After refraction, it will bend. Then finally, are you getting now? So finally, this is the image. There's a real flower. This was the imaginary flower. In what direction the shift? In the direction of incident ray. So there's a thing. Sir, what happens if I have a virtual object? It's a real flower, real object. I'll write better. It'll be easy for you. Real object. Here, what do we get? Image virtual. Now it can happen like this also, no? Virtual object, I'll bring it. Now, we know what do you mean by virtual object? Like this. So the rays appear. This is a virtual object. The rays wants to converge at that point. So, but after refraction, so this is the incident ray. Here it will undergo refraction. The ray is moving from denser, rarer to denser, should bend towards normal. Should bend towards normal. Then the ray is moving from denser to rarer, should bend away from normal. So finally the ray, I have, I'll use the similar approach we can have here. Okay, one line should come here. Okay. Then I think I'm drawing this line is very difficult. Okay. Okay, now see clearly. Now, what is the direction? This ray refraction will occur again. One more refraction. Finally, the image is here. What is this? This O, what you have is a virtual. Please, all of you, make notice. The incident ray wants to converge at these points. Okay, fine. So, as this is the air, glass, and this is air. So, what do you expect now? The ray moving from rare to denser will bend towards normal. Again, ray moving from denser to rare should bend away from normal. Finally, they'll converge at this point. Now, what is this object O? O was virtual. Huh? Virtual object. What about I? I is a real image. Again, in what direction the shift you are seeing? The shift
Away.
is in the direction of incident ray. So, what is the conclusion? Whether it's a real or virtual object, the shift will be in the direction of incident ray. Very simple. Direction of incident ray. Now, if you are here, it will appear nearer. If you are here, so I don't think so. You should be here, a virtual object. So I think virtual object, physical virtual object, not possible. Already we have discussed here. The rays which wants to converge here will converge at this point. So the shift will be in the direction of incident ray. What is the basic idea? If a slab is kept in a medium whose refractive index is less than that of the slab, then the shift will be in the direction of incident ray. Okay, you see, either it's a real or virtual object. So what is the conclusion we have to make it? And what about the shift? How to calculate? Just take help of the same formula. Shift equal to thickness of slab by 1 minus 1 by refractive index of the glass slab. If surrounding medium is there, then bring that one. Hope everyone getting. So what is the conclusion? We'll make it here. The conclusions are like this. Sir. If a slab is placed in a medium in this that of its refractive index, then shift will be in the direction of incident ray. Whether it's a real or virtual object. I'm making things clear. Whether it's a real or virtual object, the shift will be in the direction of incident ray. Okay? Now, sir, what happens if refractive index of medium more than that of slab? It can happen. Next condition we'll discuss. Now I will bring a medium. Okay, this is some liquid. We'll assume. No? We'll assume some liquid. Let there be a slab. Now clearly look at the now this is the object. Now this is the refractive index of glass. This is a liquid. Let me write mu g mu n. This is a liquid. This is glass. So mu L less than mu g. I'll write simple in this way, denser this error. Okay. What will happen to the shift according to the formula? Thickness of slab 1 minus surrounding medium mu L by mu G. What do you expect shift? So let mu L equal to 1.8 L, right? Mu G equal to 1.5. Here only we'll get it, no? Thickness will
Negative
be
shift.
10 centimeters. So 10, 1 minus 1.8, 1.5. 0.3 by, anybody value?
-2.
Minus
-2.
minus 2 centimeter. What do you mean by negative shift? Will be opposite. The shift will be opposite. So these are the things which you have to remember. Sir, how it will happen? Shift opposite means opposite incidentally. The final image will be here. The shift will be opposite. The reason is because the slab is placed in a medium whose refractivity is greater than that of its own. So you go for ray diagram again, it will go here. It is moving from denser to rarer. So it should bend away from normal. Then it is moving from rare to denser, should bend towards normal. So when you extend, will be virtual, but shift will be opposite. So what is the conclusion now? If a slab is placed in a medium whose refractive index is greater than that of its own, then the shift will be opposite to incident ray. I think these are very important conditions. Just you can't just apply the formula. You have to check who is rarer, who is denser. Let me bring this condition here. If a slab is placed medium of refractoriness greater than greater than of its refractive index, should be than of its refractive, then shift will be opposite to incident ray, will be opposite to direction of incident ray. Okay, I think this is very crucial. Such things is what student has to opposite in the direction of incident ray. All this matters. Now, I think so. Now comes the application. From here, we'll go for application. There's a theory, double refraction. There's a theory. Okay, let's get into the application part. You have to remember formula. Shift equal to thickness of slab 1 minus refractiveness of surrounding medium by refractive index of the slab. I'll start with simple examples. Let's see that how you. I have a slab. The thickness is say 10 centimeter. There is some dust particle is there, which is at a distance of say 3 centimeter. Mu of glass 1.5. This is air. And a person, two persons are there. One person will view from here. Other person will view from here. What is the distance separation between the images as seen by person 1 and 2? Now, where is the object? The dust particle, it is here. Now, this person will see, for him, where do it will appear? This person will see, for him, where do it will appear? Then the difference in those two. positions is what that is being asked here. Find the position of as seen by persons. Carry on now. Can you apply? Where is the object? Object is not outside, no, somewhere inside the slab. How do we do? Oh, I think just wait, I'll get this screen. Can you use this formula? Can we use this formula? The answer is no. The reason the object which it will emit rays, okay, the rays emitted by object here will go undergo refraction, will enter ion. The rays emitted by object will undergo refraction, will enter into ion. There's only one single refraction, no? And where is this person? Both the persons are in here. Apparent shift formula you have to apply here. The for this person, where do the image will appear? Will will appear nearer, no? I2. This is the real depth. Then what is the apparent depth? Okay, this distance how much will be 7 centimeter, 7 centimeter by mu. What about the real depth for this person? Will be 3 centimeter, will be 3 centimeter. Then how much will be 3 centimeter by mu? Suppose I will bring this, both the persons are at 8 centimeter from the slab. Will bring the person's position also. Okay, they're at what distance? 8 centimeter. Then where do it will appear for them? So first for this person, the image will appear here. For this person, the image will appear here. There's a person P1, there's a P2, you calculate. P2, say P1. P1 I1, how you calculate? P1 I1 is equal to P1O by mu, no? P1O is 3 by mu. Mu is 3 by 2, 2 centimeter. P1, P2, I2. P2, I2 should be equal to P2O by mu. P2O will be 7 by 3 by 2, 14 by 3. 4.67 centimeter. So where do the image will appear? Okay, 8 centimeter plus P2I2 for this person. For this person, 8 centimeter plus P1I1 is asking the difference in position of images. How to calculate this? Call this is X. I think what is the total length of the slab? P1, P2 should be equal to 10. What is that P1, P2 should be equal to? P1 I1 plus I1 I2 plus P2 I2 equal to 10. I1 I2 is what is asking. That is what X here. So P1 I1 already we know 2 X 4.67 equal to 10. Solve it. 6.67, it will be 3.33. Separation between images. The moment you see slab, you should not, sir, I'll apply this formula. I think try to understand the ray optics here, not like formula here. The rays emitted by him will undergo only one refraction, so apparent shift concept. If the rays undergo double refraction, then the slab will come, slab concept. The rays here emitted by it will undergo refraction here at the surface P2 and will enter into human eye. The rays emitted by the dust particle here will undergo refraction at surface P1 will enter into human eye 1. So only one refraction. No, one refraction we can't use shift formula. Double refraction shift formula will come. Hope are you getting? I wanted to just give some idea here. Double refraction, then this is applicable. I check books now. You have plenty of questions of these kind. Students want to learn through formula. No, come take help of the basic ray optics. It'll be much easier. Huh? So we are not still we didn't understood. Okay, we do one thing. We draw ray diagram. What is there? The ray will go here after refraction, denser to random. Then similarly the ray will go here. Okay, again, this also will move from denser to random. A rough diagram it is. Hope you are able to think easily here. This ray will enter into eye of the person 2. This ray will enter into the eye of the person 1. I have multiple slabs, mu1, 2, mu2, 1.5, mu3, 1.4, thickness 2 centimeter, 4 centimeter, 6 centimeter, and here. This is the object I kept it. Separation between them will be 1 centimeter. What about now? How to do this? The rays emitted by this object will undergo double refraction, so there will be shift due to slab. Again, they'll pass through this slab, there will be double refraction, there will be shift due to this slab, there will be shift due to this slab. So what we should do? We should add up shift due to individual slabs here. The net shift will be S1 plus S2 plus S3. S1 will be T1 1 minus 1 by U1. Thickness is T1, T2, T3. Okay. The same thing that the shift will be, our image will be here, and you are going to see this is shift. Add up shift due to individual slabs. Suppose the refractiveness of this slab is less than that of medium, that will become negative. Anyway, the shift can be positive or negative. Already we have discussed. Then take just algebraic sum of shift due to individual slabs here. Okay, now Slightly, I'll change the condition. We'll see how you analyze. I'll be weaving it from here. What about where do this image will appear? There's a real object. Huh? Now, where do this image will appear? The ray after passing through the slab, but look at this blue color slab. What is the adjacent slabs? The adjacent slabs are not something like air, no? So what you do with this formula? The same superposition principle. Like if only yellow color slab is present, it will have a shift S1. Then only blue color slab, it will have a shift S2. Only gray color slab, shift S3. Then take algebraic sum of shift due to individual slab. But sir, like a look at the medium surrounding this slab, it is something different. So how you can use the how you can write down the formula? Superposition principle is what should be applied here. So what is the net shift? Should equal to S1 plus S2 plus S3. S1 will be T1 into 1 by 1. This is a T1, T2, T3. Net shift. Okay, now, so first only due to yellow color slab, the shift is S1. Then only blue color slab, the shift is this one. Only blue color slab is there. Then when only gray color slab is there. So I'll so it's like this. Huh? Only shift due to yellow color slab. How much it is? 1 minus 1 by mu1. Then only blue color slab will come. Then only due to blue color slab, how much? Then only due to gray. When all three are present, what shift will get? The same thing. So this is some very small basic things which a student has to learn. So one slab or two slabs, I think you can manage now. Let's take the silvered slab will do it. If a slab is silvered, what conditions will come? So this surface is silvered. I'll keep object O, thickness of slab 6 centimeter, refractive index 1.5. Then where do the final image will appear? I'll make it a little bit small. Okay, come for this object is here. Where do the final image will be? Let's how we manage here. So what will happen to the rays? It is like this is equivalent to mirror come slab. Huh? This is equivalent to first a slab, then comes a mirror. Are you getting no? So now we know the basic things like shift due to slab, we know it. Equivalent mirror comes slab here. This is silvered slab. What is this? Silver slab. Now what is this equivalent? Mirror, and this is slab. The same thing, all parameters are same. Now first this object, let it be at a distance say 32 centimeter from the surface P1, this is P2. Now 32 centimeter object is at a distance of 32 centimeter. So what this slab will do? So this mirror will look the object through the slab. Please try to understand. Now, who is the observer? The mirror. Let's say that you are here. You are going to see the object through the slab, no? So what the slab will do? Will produce a shift here. So it will appear at O dash. Very simple ideas here. Please try to follow. Then, what is the shift formula? T into 1 minus 1 by 6, 1 minus 3 by 2. Two centimeters is the shift. So for the mirror, where do object will appear? 6 plus 30. So what is O dash? O dash will be 30 centimeter. Correspondingly, it will form image where I dash. At what distance? 30 centimeter. It will form the image corresponding to O dash. It will form image I dash. The mirror, what will do? Corresponding to O dash will form I dash. What is the object distance? 30 plus 6. Sorry, 36 centimeter. For the mirror, the object will appear what is the distance from O dash to the mirror? P2. P2 O dash should be equal to, object distance should be equal to P2 I dash, which is equal to 30 centimeter. Now after reflection, what will happen to the rays? They will again undergo double refraction. The rays will undergo refraction, now reflection. Again refraction, again refraction. So again there will be shift. What is the direction? Now what is the after reflection, in what direction the rays will move? Towards light. So finally the image will be here. How much this shift should be put? Again 2 centimeter. So finally at what distance will be? 34 centimeter it will be there finally. What is the distance of this will be? 34 centimeter. You get it now? 34 centimeter will be the distance, final image. So final image will be 34 centimeter from the silvered surface of slab. Actually, you should draw the ray diagram. I am leaving the ray diagram to the students. You have to draw a ray diagram here. Ray will come, the ray will bend towards normal. Then again one more refraction. It will strike here. Then finally the ray should diverge from I. You should draw the ray diagram. I want students to draw the ray diagram. You move this mirror slab little bit, no, it will be easy for you to draw the ray diagram. Let me show that ray diagram. Just for our convenient, we are shifting it. So first the rays. I need big diagram. No? Look at this. Rarer to denser should bend towards normal. I should increase the width of the slab. I'll bring it. Ah, this is very important. The student has to not just mere formula. You should work out. Finally, the ray is ray optics is all about the effort. Final image. Real, virtual. Okay, can you analyze like this? So there's a method of silver slab here. Just a one small concept. It's not something wide application will be there. This is one of the concept here. Okay, now what we do is like we'll bring some spherical mirrors. There's a plane mirror. If it is placed near spherical mirror, then we'll see what conditions will come. This is a slab. Should be silvered even. This is a convex mirror. This is a focal length F. The rays are, I'll bring the rays. Rays, is a ray. A parallel beam of light is incident on it. What will happen to the rays after refraction? Focal length of the mirror I'll give plus 10 centimeter, thickness of slab 6 centimeter, mu 1.5. I'll give this distance 20 centimeter. Carry on now. So look at the rays from where they are coming from infinity, no? Now anything can happen, the rays, the angle of incidence equal to angle of refraction. The rays will go undeviated. They'll strike here the incident parallelly. So after refraction, they should diverge from the focus, no? The rays should diverge from the focus. Okay, let's do one thing. So the refracted rays will diverge from the. Now what will happen to the rays? Yes, definitely they are going to undergo refraction. Am I right? Let's get into what will happen to the rays here now. These rays should not disturb this one. Let's not disturb the slab. The rays which are incident here, angle of incidence equals 0, angle of refraction 0. So they go undeviated at the first phase. Second phase undeviated. They're incident. Now they're incident on convex mirror. So after refraction, they should deviate from the focal length, from the focus. Yes, it is. Now what will happen? Now angle of incidence non-zero, so they will undergo double refraction. What shall we do now? How we will manage? Yes, you must take help of ray diagram here. Then only it will be easy for you. You'll be in a better position. Then after this, you bring one more horizontal line here. The rays are moving from rarer to denser. The rays are moving from rare to denser. They should bend towards normal. Rough diagram it is. Rough diagram. Now what will happen to this? Again, they're moving from denser to rarer. Should bend away from normal. Hope everyone is able to understand. I am somewhere here. I have to show like this. After refraction, okay, fine. So where do the shift will be in? So we do get here. How to calculate this one? Anybody wants to answer? Actually, the rays are coming from focus here. Finally, what will happen? They will appear to diverge. They should diverge from focus, but they appear to diverge from the image eye. This one. So what is the direction of shift? Towards left. So what is the value of shift? Shift should be equal to t into 1 minus 1 by v. T is how much? 6 centimeters, 1 minus 3 by 2 centimeter shift. Now, if I vary this distance from 20 centimeter, I'll make 10 centimeter. Any difference will it make here? I'll change the. I will vary the distance between the slab and the mirror. This distance, if I vary, so anything will happen now. Anything will, this position of image will change. Somebody should answer this. Huh?
Shift will remain same only.
Shift will remain same. There won't be any difference. So these are the more troublesome questions. This you can answer only when you draw ray diagram, not the formula. Getting all of you? So still you have to confine yourself to the ray diagram. There is a basic way of learning. Formulas are like a conclusion. We are just going to conclude that easily. But the learning part comes through ray diagram only. You must have a patience to draw like this. First patience, like okay, after refraction. Okay, we know final image will be here. So in the direction of shift. Now having this idea, you should proceed here. Okay, yeah, the separation between the slab and the mirror will not determine the position of image here. This can be 10 centimeter, 20, 100 centimeter, doesn't matter. Anybody having doubt, you can clarify. Completed.
Yes, sir.
Concave mirror will take it. We'll have concave mirror. I think. Let it draw the diagram first. The concave mirror. We can draw a small mirror with respect to vertical line. We'll discuss the problem. It will be much easier. So it's a concave mirror. I am going to bring a slab. So focal length. Okay, this is a x. This is a t. This is a mu. Focal length. Now one vertical line will draw it. All our calculations will be based on that one. Ray diagram with respect to vertical line will show the reflection due to concave mirror. A focal length 10 centimeters. What are the data? Mu 1.5. Thickness of slab 6 centimeters. And the object distance PO is 17 centimeters. So first case, x equal to 3 centimeter will take it. We will move the slab 20 centimeter. I think I moved it a lot. Sorry, 32. Yeah. Real object is kept here. You have to calculate the position and nature of image when the distance between the concave mirror and slab is 3 centimeter and 20 centimeter. Find the position of image due to find the position of final image due to refraction at slab and reflection at spherical mirror. And how you make it this? First, there's a real object. So mirror will see the object through the slab. So the object will not appear here. So will appear at this point. Say I1. So what is the basically shift? Shift is equal to 6 into 1 minus 3 by 2. So this will be 2 centimeter. Okay. And now we do this. Object is at 32 centimeter. Focal length of concave mirror is 10 centimeter. For the mirror, the object will not appear at O, will appear at I1. Okay, fine. Next, after this, we'll apply the mirror formula. 1 by Pi2 Pi1 equal to focal length. Pi1 will be 30 minus 15 centimeter. Is this the position of final image? So actually we should now really should draw the ray diagram. Otherwise we can never learn this problem. So x equals 3 centimeter, I'll modify it. Or we'll have one more diagram with this big question. Now the slab has to be somewhere 3 centimeter. Then we have to work out here. I will take out this part of the diagram. We'll draw the ray diagram for x equal to 3 centimeters. Now what was our all the data I'll bring down. So it'll be easy for you to 3 centimeter. Somewhere I'll bring it here. Okay, we'll proceed now. What is our thing? Final image, where it will be? That was our question. No? Okay, this is x equal to 3 centimeter. Okay, let's get into the ray diagram. First, what happened? The rays, after passing through the slab, will undergo double refraction, will appear at I1. Now, the concave mirror will form image due to I1 that will be at 15 centimeter. Again, the reflected rays will pass through the slab. No? So 15 centimeter will be somewhere here. Let's assume that one. Again, the rays after reflection will pass through it. So final image will be somewhere here. Getting now. So 15 plus 2, how much it is? 17 centimeter. This will be our final image. Pi3. Sir, what about the ray diagram? Yes, now we can proceed here. So it will be like this. Let me try. After double diffraction, I'll show you. Okay, this is then refraction will occur. Where is that P, P, P? Some length of the slab, let me increase. Now, after refraction, the ray, after refraction, the ray wants to meet at I2, no? Okay. Wait, and I'll use that dotted, which will this will help us. This will be much easier. No? Refracted ray, reflected. Finally, Okay, some diagram somehow I adjusted it. Okay, this is a ray diagram, so you must be in a better position to manage all this. This is slab. Surrounding medium is air. What was the distance? We took x equal to 3 centimeter. What will happen if x equal 20 centimeters? Again, the rays will undergo double refraction, reflection, again double refraction. The idea is same. Now, what about the rays? Again, you send rays below the axis. Finally, they'll converge at a point. So, what is this? I3 will be real. We had here a real object and there's a real image. There's a real object, there's a real image. Hmm? Okay, now we'll go for x equal to 20 centimeter. The things are same. What is this image? Now x equal 3 cm will be real. So what will happen to the image is what we have to check it. Okay, I need same diagram. Drawing diagrams, ray optics is all about drawing ray diagram. Huh? So second case, x equal to 20 centimeters. So I should move away this slab, no? Yeah. So where do this slab? I'll better to bring another one. Actually, same slab only that is. So I'll bring it here. 20 centimeter. I'll bring it somewhere here. I have to redraw. I'll redraw everything. Get confused again. Now first object is here. So image I1 is formed. The slab is somewhere here. And image, final image I2, this I2. So again after reflection, again they'll pass to the slab, no? First refraction, reflection. And so the ray diagram will be let me give a better diagram. So after refraction, double refraction, the ray. So this is the, then after reflection, The ray wants to converge here, so it will converge there. Red color, let me use the rays above the no. Will the ray will stop here only? No, they'll further proceed. No, they'll further proceed. So again, and finally, they will deviate from, they will diverge from this particular thing. So this is the now similarly the rays emitted by this below the axis, they'll undergo refraction. So if I, let me try again. So after refraction, I'm giving colors here so that it will be easy for you which ray is particular thing. So this is the I1 and there's a final image. Okay, there's a one arrow, two arrows, after reflection, three arrows. You can see it. And finally, there's a thing. Okay, the final, what is this image? Formed due to diverging refracted rays, no? These are the incident rays. These are the final reflected rays. So what is this image now? Object was real. What about image? Image will be virtual. I3 is final image. Okay, this X is, I'll show here, X equal to 20 centimeter. I3 is final image and it's virtual. O is real object. What about the previous case? Previous case, I3 was real. Huh? Only the rays will converge at this point. This image is formed due to converging refracted rays. So what was I3? I3 was, O was real object. I3 is real image because it is formed by the converging refracted rays. This is very important. Just by moving the slab, the nature of image will change, the position of image will not change. Now also what is PI3? PI3 will be 17 centimeter only. Hope everyone is able to understand. I'm trying to reflect some better ideas. The position of slab will change the nature of image, not the position of image. So what is the comment you can write here? By changing the position of slab, the nature of image may change. If you move it here only, may not know, somewhere here like this, far away. Because what is the shift? Shift will be in this direction. Now you can see the shift here was like this. Let me use some other color. Yeah. This was the shift. Now this is the shift. Altogether, the shift will be in the direction of incident ray only. This is thickness. Later on in the notes, check it. These diagrams are very important. Drawing such diagrams is what your ray optics are. Because we don't have much, mirror formula, You know the shift formula, so anybody can substitute and solve. It's just only mathematics. No? It's all about the ray diagram. So how to draw the ray diagram? I think this is one primary best question you can ask it. Let me. So how to draw the ray diagram? How to draw the ray diagram is so start from here. This is a real object. So what should happen to incident rays? Should diverge from O, real object. Yes, the rays here after double refraction will be incident on the plane mirror. Sir, how do you come to know that this I2 will be here? Can't it be here? I think you have the length, everything. What is PO? We know object distance 30 centimeter, 32 centimeter. Same thing, I didn't change anything data. The data is same. Then PI1 how much? 30 centimeter. So the mirror will see the object through the slab. So therefore the object will appear nearer. This is the idea here. For the mirror you see that the rays are coming from I1, not from O. Please open eyes. You have to make observation here. For this mirror, sir, where is the mirror? Here no mirror. I think with respect to vertical line we do show. Because the diagram will become little bit very neat. It's mirror only here. So the rays from the object will happen undergo double refraction. For the mirror, the rays will appear from I1. So this is the effective objective object distance for the mirror formula PI1 30 centimeter, focal length 10 centimeter. Then if focal length 10 centimeter, apply mirror formula. Then we'll get the final image will be by the mirror will be I2. Then after the rays will not stop here only, no, will pass through the slab. Now they'll diverge from I3. So what they shift again the same formula. The only thing is the image will be virtual. Okay, so what is the conclusion we can write here by shifting the slab? The nature of image changes. That's all. Not the position of the image. Now we'll have one more. There's a concave mirror. We have the virtual object somewhere here. This will be again, I'm bringing the idea of virtual object. The rays wants to converge at point 2. So where the object, virtual object, is there in the slab. 6 centimeter, 8 centimeter, 1.5 into 1.6. This distance, let it be 2 centimeter. Focal length. Concave mirror 10 centimeter. Let this be equal to 16 centimeter. So look at this, the rays. The virtual object is at a distance 2 centimeter from one end of the slab. Then after reflection, we want after reflection, where the final image will be. Find the virtual object is located at a distance of 2 centimeters from one side of the slab. One as shown. Find the position of final image. Okay, what to do now? So let's see that. See, now, whenever two slabs are there, what you are going to do? The same idea to superposition. So first the rays which are incident on slab will undergo refraction here. They want to converge at O, but this surface here, this boundary will not permit it to converge at O, virtual object. So they'll undergo refraction. Again, assume that this slab is not there. They'll undergo refraction here. The surrounding medium is here. So they'll undergo refraction. Then they'll fall on mirror. Similarly, if this slab is there, again refraction. So the same shift formula we have to bring. First, like what is the next shift? T1 into 1 inverse. T1, 6, 1 minus 1.5. 8 into 1 minus 1.6. This will be 2. This will be 10, 5 by 8. 3 centimeters. Anybody check the value and answer me? I'll make it 10. It'll be very easy for me. Shift 5 centimeter.
Yes, sir.
Yes.
Okay, fine. Okay, now, what will happen here now? So the final, due to the slabs, will form the image of this virtual object somewhere at I1. What is that I1? I1 should be somewhere here. I can move this distance. So this will be the focal length. So it will form the image at the focus. No, somewhere here. No? After double refraction, it will be like this. Then they'll, from here, the rays will be incident on the mirror. We'll apply the mirror formula first. So O dash, this will be 4, 5. So image will be here. I1. We'll apply mirror formula. One by pi2. pi1. pi1 will be minus 15. Focal length minus 10. pi2 will be minus 30. What do you mean by minus 30? It's very easy. Problem will get over now. If you have small data like this. Minus 30. What do you mean minus 30? This is 10. 8 plus 6. How much you get? 14, 24. So 30 means somewhere it should come here, no? The final image here. So again the rays will undergo double refraction. Ray diagram, sir, ray diagram. It is I2. Then again shift will be there, final image. How much of shift? 5 centimeter. So what is the final image from the mirror will be? 35 centimeter. So how come you can, without ray diagram, see what this slabs will do will make them to shift and the rays will diverge from I1 for the concave mirror. What concave mirror will do will form image of it. At 15 centimeter it is there. So then it's going
17, sir. It should be 17.
this one. Huh?
I1's PI1 will be minus 17.
Shift is how much? 5, no?
Yes, sir. So 2 plus 5, 7. So out of 14, 7 centimeters means from the pole, 10 plus 7.
Oh, like that. 5 centimeter means here 2 is there. 1 will be there. How much will be remaining here?
17 should be there.
17 should be there. Huh? Okay, I'll change it here. Anybody PI2? Ah, 17, no? It should be. One 70 by 7,
24.28.
24.28
28.
centimeter. Ah, okay, fine, PI2. Then it will be shifted further by 5 centimeter. Okay, this 5 centimeter. This will be our final image. Huh? Real or virtual? Anybody wants to answer this? Hmm. I want students to answer this. Virtual object. Real image. Huh? How do we can say that? Because the rays here, they'll come here. So after reflection, they wants to converge at point I2, but the slats will shift it and they'll come here. Sir, can you draw a ray diagram? Yes, again the same method. The ray diagram will come like this. But finally, they'll undergo double refraction. Red color. I'll show the refraction somewhere like this. You should undergo actually the double refraction. Net I'm showing it. Okay. So this is the after double refraction. Okay, this will be 5 centimeter. I think you can manage, no? So the shift will be one slab, two slab, concave mirror, convex mirror. Now this slab will come wherever it wants. What the particular slab will do will produce shift in the direction of incident ray. Provided if the refractiveness of medium of the slab is greater than that of surroundings. I think now try to work out. So try to think on the different, again, varieties of problems. I'll end up the class. Yeah, thank all of you. Okay, kids, like we had a discussion about the refraction of double refraction. So the slab idea we brought, then first shift due to the slab, the formula was shift equal to T into 1 minus 1 by mu, or 1 minus mu 2 by mu 1. Mu 2 was refractive index of the surrounding medium, mu 1 of that of the slab. Surrounding medium is air, then mu 2 will be 1. It will become S equal to T 1 minus 1 by mu. Okay, that's about the formula. Shift in the direction of incident ray. So whether real or virtual object, the shift will be the direction of incident ray. Then that particular slab is brought nearby plane mirror, nearby the concave mirror, convex mirror. What the slab will do will produce only shift, that's all. Of course, the position of slab will determine nature of image. Like this, the type of problems is what we have come across. Okay? I'll end up the class. I think it's already too late. Okay, thank all of you. Yeah.